Welcome to the CompTIA A+ Prepcast presented by baremetalcyber.com. Installing an operating system is one of the most common tasks performed by IT technicians. The method chosen to perform the installation depends on the type of system, the scale of the deployment, and the tools available in the environment. Whether setting up a single desktop, configuring a new laptop, or deploying hundreds of machines across a campus, understanding installation methods ensures the job is done efficiently and correctly. The A+ exam expects you to recognize each method and understand when to apply it based on the situation. The most widely used method today is installing the operating system from a bootable USB drive. This approach is fast, convenient, and widely supported across both modern and legacy hardware. A bootable USB drive is typically created using tools such as Rufus, Balena Etcher, or the Windows Media Creation tool. Once prepared, the system's BIOS or UEFI must be configured to boot from the USB device. This method works well for personal installations, quick field support, or lab setups where physical access is available. ISO-based installations are another common option. An ISO file is a complete disk image of installation media, often used to install an operating system in virtual machines or to automate deployments. ISO files can be mounted directly inside a virtual environment without needing physical media. They can also be burned to a USB drive or DVD for installation on physical hardware. When paired with scripting tools or automation platforms, ISO-based installations are used for custom builds and consistent configurations. DVD installation is still found in legacy environments or systems that include optical drives. Although slower than USB or network methods, D versus Ds may be used for recovery tools or older operating system versions. The BIOS must support booting from an optical drive, and the media must be clean and undamaged to avoid read errors. As optical drives become less common, DVD installation is gradually being phased out, but it is still included on the A+ exam as a legacy concept. PXE, which stands for Pre-Boot Execution Environment, is a powerful network-based installation method. It allows a system to boot from a network server rather than a local disk or media device. This process relies on a network interface card that supports PXE and a properly configured deployment server. PXE boot is most commonly used in enterprise environments for mass deployment, especially when combined with tools like Windows Deployment Services or Microsoft Endpoint Configuration Manager. The PXE boot process follows a defined workflow. First, the BIOS or UEFI must have network boot enabled. When the system starts, it contacts a DHCP server to obtain an IP address and boot server details. Then, it downloads a boot file from a TFTP server. This file loads an operating system installer or imaging environment directly into memory. PXE deployments reduce manual setup time and allow centralized control of system images, drivers, and post-install configuration scripts. Another installation option is using a network share. This method involves accessing installation files stored on a server or shared folder over the local network. A technician mounts the shared folder using a mapped drive or UNC path, then launches the installer from there. While not a bootable method, it is useful for initiating installations once a basic operating system or recovery shell is available. This approach requires valid credentials and active network connectivity, but allows for flexible, centralized management. Cloud-based delivery is increasingly common, especially in modern Windows environments. Microsoft, for example, offers the option to reset or reinstall Windows using cloud download instead of local files. This requires a stable internet connection and a supported system, but ensures that the latest installation files are used. Cloud recovery is also available on some mobile devices and thin clients. It is particularly helpful for remote rebuilds, quick disaster recovery, or scenarios where installation media is not physically available. Each method serves different use cases. USB installation is ideal for general-purpose setups, including field service or home computers. PXE is preferred for large-scale, enterprise-level deployment, where consistency is critical. ISO files are often used in virtual machines, scripting environments, or when creating fully customized installations. Network shares work well for help desk technicians who need to access shared resources without carrying physical media. Technicians should choose based on speed, scalability, and infrastructure access. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Unattended or scripted installations allow technicians to automate the entire setup process by using answer files. These files contain predefined responses to all the prompts normally seen during installation, such as language settings, time zone, disk partitioning, and user account creation. When used properly, unattended installs save time and ensure consistent configuration across multiple systems. They are especially useful in lab environments, schools, and corporate deployments where hundreds of identical systems must be configured with minimal variation. Some systems include an OEM recovery partition, which is a special disk partition containing a copy of the original factory image. These partitions allow the user or technician to restore the system to its original state without external media. Recovery partitions are often accessed by pressing a specific key at startup, such as F11 or Shift plus Restart. While convenient, they usually restore the system to an older state and may include bloatware or outdated drivers. Recovery partitions are still common on laptops and business desktops provided by major manufacturers. Technicians must also understand the difference between an in-place upgrade and a clean installation. An in-place upgrade installs a new version of the operating system while keeping existing data, apps, and settings intact. A clean install wipes the drive and starts fresh, which is better for removing malware, performance issues, or legacy software conflicts. Whether to upgrade or start clean depends on the system's condition, the presence of backups, and the deployment goals. The A+ exam may include questions asking when to choose one method over the other. Multi-boot configurations allow a single system to run more than one operating system. At startup, the user selects which OS to boot into. Each operating system must be installed on its own partition or dedicated drive. Multi-boot setups are useful in dual-purpose environments, such as testing labs, developer workstations, or compatibility environments. For example, a technician may install both Windows and Linux on the same laptop to test software across platforms, or to use Linux-specific tools. Here is a common troubleshooting scenario. A technician creates a bootable USB to install Linux, but finds that the target computer refuses to boot from the drive. The issue could be that the BIOS is not set to prioritize USB, or that secure boot is enabled and blocking the installation. The technician should first check the boot order in the BIOS, or UEFI, then confirm the USB was properly created using a verified tool like Rufus. Trying a different USB port or recreating the boot media often resolves the problem. Secure boot is a security feature found in most UEFI systems. It prevents unsigned or unauthorized operating systems from loading during startup. While useful for preventing malware and unauthorized access, it may block the installation of Linux distributions or custom-built ISO images. If compatibility issues occur, secure boot can usually be disabled from the UEFI settings. Technicians must balance security concerns with installation requirements and always confirm whether disabling secure boot complies with organizational policy. File systems are another important consideration during installation. Windows typically formats system partitions using NTFS, while Linux defaults to ext4. Boot partitions, especially in UEFI systems, are often formatted with FAT32 to ensure compatibility. During setup, Installers may offer automatic partitioning or allow manual control over how storage is allocated. Understanding which file systems are supported and how partitions affect boot and recovery is important when setting up or troubleshooting multi-boot or customized systems. The Windows installation process follows several distinct phases. It begins by copying installation files from the media to the system drive. Next, the files are expanded and prepared. Then, system features and drivers are installed. Finally, the system transitions into the out-of-box experience, also called OOBE, where user accounts and privacy settings are configured. During installation, logs are created in files like setapack.log. These logs are essential for diagnosing failures or unexpected behavior during deployment. If an installation fails, technicians should follow a methodical troubleshooting process. First, confirm that the installation media is not corrupted by testing it on another system or re-downloading the ISO. Next, check the target system for hardware problems, such as failing memory or unsupported devices. Reviewing installation logs helps identify specific error codes. In some cases, switching to a clean boot environment or using an alternate install method like PXE instead of USB resolves the issue. Troubleshooting skills are critical, especially in environments where time and reliability matter. To summarize, technicians must understand and choose the appropriate installation method based on the scenario. USB and ISO methods are fast and flexible, ideal for most individual setups. PXE boot is used for enterprise-scale deployments, while network shares provide lightweight alternatives when media is unavailable. Cloud-based and recovery partition options add convenience in modern devices. The A+ exam tests your ability to match the method to the situation, interpret troubleshooting results, and ensure successful deployment across a wide range of systems. Thank you for listening. Please visit baremetalcyber.com for more cybersecurity information, podcasts, books, and more.